last speaker for the session. So Fernando Jaramillo is going to be speaking to us about determining the hydrological implications of regulation on Swedish lakes with space observations.
Okay, thank you very much, and thanks for bearing with me. I know I'm the last one, so I promise I'll be brief, not a lot of text and a lot of images, so that you don't fall asleep. So basically the idea of this study was, as you see here, you have on the left a satellite. So the idea was to try to see if we can detect water changes from space in Sweden. So Sweden here, which you have here on the right, there's almost more than 100,000 lakes in Sweden, or open water resources in Sweden. So looking now at the left, now there's a big concern on how water is and how water will change in the future. In Sweden, we're very used to having water all the time, so we haven't been very concerned of how much water it's on our resources until recently, 5 years ago, where we had a very bad summer, especially in southern Sweden, and we had like some water shortages. So now there's some concern. Okay, how are these resources changing in time now? So we said, okay, let's do this assessment. Let's see how water levels are changing in Swedish lakes. But then, yeah, exactly. And then we said, okay, and knowing as we learned yesterday from several talks, a lot of these lakes in Sweden have been regulated during the last 150 years. So what are the implications of a lake being regulated or not? How are water levels changing in these lakes? So these are the two main research questions that we had. So, but then we said, okay, let's do that. So we asked, okay, where's the data of lakes? And they were like, no, well, we have 39 lakes. And we're like, oh, that's not a lot. It's less than 0.1% of all the Swedish lakes. So we're like, oh, maybe this is a good opportunity for our research project, like try to see how Swedish lakes are changing, right? So then we said, okay, there's a technique that's called altimetry, and altimetry measures the time that a signal from the satellite takes to go from the satellite to the surface of the Earth. So in that sense, you can know the elevation of water in a specific resource. And fortunately, we have also several altimetric missions that in this case, for the case of Sweden, they go back even to 1995. So if we can get all this satellite mission information available and connected, we could actually get water level trends for the last, that's what, like 20, 25 years. So we said, okay, let's do that. But unfortunately, not a lot of the lakes fall under the orbits of the satellite. So we cannot do this for 100,000 lakes. And obviously it will take me my entire life doing this because it's not also as easy as we thought. But we could indeed identify several lakes that are falling between the orbits of these satellites, and which accounted more or less for 150 lakes. So the job was really to see how these lakes, how the water level in these lakes is changing in time. And here, for instance, we found that, so I'll focus between the period 2013 to 2022 because that's where we have more data. And here on the left, you see the map where we see the mean dynamic storage, which is of each of these lakes. It means the depth of oscillation between maximum and minimum water levels in these lakes. So you can see that actually the highest values are located in northern Sweden. So there's higher oscillation of water levels in lakes in northern Sweden than in southern Sweden. And then on the right, we try to determine changes to this water storage. And we see that generally across Sweden, there has been an increase in water storage during these 10 years. And then water level, we said, okay, now let's see how water levels are changing in time. So here we took the sample of 150 lakes that we had, and we saw a very interesting pattern. So we saw that actually in northern Sweden, there has been a more or less general increase in water level in lakes, whereas in the south, there has been a general decrease in water levels. So this, in some way, if you assume that water levels are water, they can be used as a water variable. It basically becomes wet, it's becoming wetter, dry, it's becoming drier, because everybody's saying northern Sweden's becoming wetter, so here you see it in lake levels, and southern Sweden is becoming drier, as we have seen so far in the last years. So, okay, so that's an interesting pattern. And then we said, okay, and then what, if a lot of these lakes are regulated, what is the impact or the effect of these lakes being regulated or not on these trends? So we came up with 4 categories of regulation. We worked with 5 data sets of regulation worldwide. And so on the left, you have N, which is non-regulated. In the second bar graph is upstream regulated. So these are lakes that are not regulated per se, but they receive regulated water from upstream. Then R is lakes that are being regulated per se in situ. And then U plus R is lakes that are regulated all over because they're receiving regulated waters and also regulate water. And what did we see? We actually see that lakes that are regulated are actually, this is the water level trend, are actually increasing more than the other categories. So regulated lakes are finding a larger increase in water levels than non-regulated lakes. And then we also try to see, okay, are there patterns between regulation and non-regulation, north-south? And remember that this is all based in satellite observation. So most of it's just determined from space. So we see that, for instance, here on the north, where you start seeing that the patterns between regulated and non-regulated lakes are more or less similar throughout the year. So this is just this is the relative water level relative to the minimum level of the lake across the year from April to November. Why did we exclude winter? Well, because most of those winters the lakes, the water is frozen, so the method doesn't work that well. But in the south, we see that actually, like you see the hydrographs of regulated lakes and unregulated lakes, they're completely opposite. So there is a distinctive pattern between regulated and non-regulated lakes, and that has obviously implications for the ecosystems and so. So these are just 150. So imagine the task of trying to see how all these lakes are changing in time. Fortunately, there's an upcoming mission that was recently launched by NASA, which is called the SWOT mission. So the SWOT mission will help us detect in real-time water level observations in Sweden. And Sweden actually is one of those countries where some areas of the country will be able to be monitored twice per day during the next 8 months. So it's a great opportunity to understand how these lakes are changing. So in conclusion, so we're trying to do a country scale assessment of water lake level changes. We managed to get some successful observations, which corroborated with several lakes that had measurements, and there was a good agreement. And we found interesting patterns between north and south, and regulated and non-regulated lakes. Okay, that's about it. Thanks.